Hi there, and thank you so much for joining me. This video is the second in our series talking about or providing an introduction to statistics. So this is Module 8, and in this video I'm going to talk about various options that you have when it comes to displaying and organizing statistical data. Okay, so first off, let's start kind of at the beginning and define what statistics are. So statistics essentially have two important functions. So the first thing that statistics do is they allow us to summarize large amounts of information or data in a way that's accessible to us or more accessible to us. And the second main function of statistics are to allow us to use those data that we've collected to answer real world questions. So one kind of natural way to think about statistics are that statistics allow for organizing, describing, and interpreting information, and they function as scientific tools, essentially, for us. So when we talk about statistics, we can divide it as a field into two major types. So first we have descriptive statistics, okay? And just like the name suggests, descriptive statistics are going to describe or summarize information, okay? And descriptive statistics are things like statistical averages, right? Like the mean, the median, and the mode. And also different measures of variability, so like the range or the standard deviation, okay? Because all of those values are essentially summarizing a data set, right? So when we ask what is the average height of people in the class, we are attempting to get a sense of the entire data set using only one value. Next, we have what are called inferential statistics. And this is the second part of that goal, right? Descriptive statistics is the first part where we're simply summarizing and organizing information. And inferential statistics is the second part where we're attempting to answer a real world question, okay? So with inferential statistics, we're making inferences about a larger group, in this case the population, on the basis of the data that we have, or using the data that we have, okay? So with inferential statistics, we're using the data that we've collected from our sample and using that sample data set to make inferences or find things out about our population of interest, right? So for example, what can data about the heights of students in this class, right, tell us about the heights of students across Mercer's campus? Okay. So frequency distributions are used to display large amounts of data, okay? And this is most commonly done using a table or a graph, right? So what are the benefits of a frequency distribution, or why might we use a frequency distribution? Okay, so let's say I give an exam and I have 50 different students in my course who took the exam, right? So given these data, right, how can I reorganize it to make it more informative, right? Because right now it's just kind of a jumble of numbers, and I'm not really able to extrapolate any useful information from it, right? So how can I make the way that my data is being displayed more informative? So one option would be to present our data in a frequency table. So with a frequency table, in one column, I would input the exam scores or grades. And in the other column, I would put the number of students who got that score. Okay, so again, this table shows the frequency or the number of students who got a particular grade on the test, right? So 2 students got a 77, 3 students got an 83, 4 students got an 89, etc. So go ahead and take a look at this table for a second and think about the kinds of questions we might be able to answer simply using the information in this table, right? So without actually computing any statistics, what sort of information can we gather simply by looking at the table? Well, there's a couple of things, right? So one thing that jumps right out at us, right, is the highest and lowest exam grade, right? Because they're ordered numerically, right? So the lowest exam grade is a 77 and the highest exam grade is a 98, okay? And that also gives us, and this table also gives us a sense of what the most common grades are, right? So the most common grades are those with a higher frequency, right? So any value that got a 4, okay, or any score that got a 4, okay, is going to be more common than a score that got a 1 in the frequency column, right? It also gives us a sense of what the average score might be, right? And we can also look at, if we didn't know that there were 50 students in the class, we could find out the total number of students in the class simply by counting the numbers in the frequency column. And we could also calculate the proportion of students that got a particular grade, right? So for example, if I wanted to find out how many students got a C on the exam, right? A C ranges from a 70 to a 79, right? So I would just look at any score that is a 70, right? And count up all of the associated frequencies and divide by the total number of students in the course or the total frequency, right? So we don't have anything below a 77, so I'll start there. We have 2 students who got a 77, 1 who got a 78, and 2 that got a 79, right? So what that means if we add those values up is 5 out of 50 students got a C, right? So 10% of the class got a C. Okay, so again, without doing any sort of mathematics, right? Well, I guess we did sort of just do some mental math, but simply by glancing at the table, we're actually provided with a lot of information almost immediately. Okay. Another option is what's called a frequency graph. Okay, so when we present the data in a frequency graph, on the x-axis, there is a bar for every value or grade that was found in our sample. And on the y-axis, this is where we would plot the frequency or the number of students that got a particular grade, right? So we see here, if we look on the x-axis at 75, no students got a grade of 75, so there's no bars there. But if we scooch over to where the 77, you know, between 75 and 80, where we think the 77 is, we have a 2. And as the bar obviously gets higher, that's going to indicate a greater frequency, right? So on grades that had a higher frequency, such as an 83 or an 87, those would have the frequency of 4, as you can see by looking at the y-axis. Okay, and again, the height of each bar shows how many people got that grade. So a frequency graph is another example of how we can glean a lot of information simply by glancing at first glance rather than having to do any sort of calculation. Okay, and the overall pattern of the scores, okay, or the shape of the bars, okay, is called a distribution of scores, okay? So the overall pattern of the scores is called a distribution. So we have a couple of different options with frequency tables and frequency graphs. So they can be either grouped or ungrouped. So with ungrouped frequency tables or graphs, each possible value or every score in our data set has its own row or bar, as opposed to grouped, where each row or bar represents a possible range of values, right? So because we're talking about exam grades, right, and we have different ranges that are meaningful, right? So we have a discrete set of values that correspond to a letter grade, right? So 70 to 79 is a C, 80 to 89 is a B, and so on. Perhaps it would be most informative in this case to use a grouped frequency table or graph because we can again gain a lot of information easier that way. So we can see very clearly the number of students who got a C, the number of students who got a B, and so on. It also makes sense to use a grouped frequency table or graph when you have a lot of data or a lot of different exam scores because it's again going to be easier in terms of what or how easily you're able to take in information when you don't have a lot of different bars that you're trying to assess at the same time, right? So whenever you have a range of values that is meaningful, or whenever you have a very, very large data set, it probably makes sense to choose grouped over ungrouped. We also use different types of graphs depending upon the kind of variable that we're talking about, right? So say that you are graphing a continuous variable. So a variable that either falls on a ratio or interval scale. When you graph those variables, okay, the bars are going to touch because the possible values are not discrete, okay? So the possible values can overlap, okay? So that's why the bars touch when you graph continuous variables. And when you graph continuous variables, it's called a histogram, or the particular type of graph you use is called a histogram, where the bars are touching. If you are graphing a categorical variable, so a variable that falls on either a nominal or ordinal scale, okay, the bars are not going to touch because each category is discrete or non-overlapping, okay? Okay, so this was just a very brief introduction to displaying and organizing data. And my next video, we'll start talking about those descriptive statistics that I mentioned. Okay? All right, so I will see you in my next video.